So today we'll be looking at the t-test. So what exactly is the t-test? So the t-test is a statistical method that is used to determine whether there is a significant difference between the means of groups. So quickly today we'll look at the three types of t-tests that we have here. Okay, so we'll talk about the independent t-test. We'll look at the independent t-test, and then we'll talk about the paired t-test also. And we have one type of t-test that is missing, which is known as the one samples t-test. Okay, so let me start with explaining what the one samples t-test is. Okay, the one sample. So it's known as the one sample t-test. So it's not here. I haven't included it here. Okay, so it's called the one sample t-test. So remember, we have three. We have the independent t-test, we have the paired t-test, and we have the one sample t-test. So what is the purpose of the one sample t-test? So what actually the one sample t-test does is that it tests whether the mean of a single sample, differs significantly from a known hypothesized population mean. Okay, so here what you have under the one sample t-test, you have the mean is known here. Okay, so the mean is known here under the one samples t-test. Okay, so an example could be maybe if you phrase a research question, say your research question is the average systolic blood pressure in a sample of 50 patients or 100 patients different from the standard 120 milligrams of mercury. Okay, so that is a one samples t-test. So remember, in the one samples t-test, you have a known or hypothesized population mean. Okay, now coming to what is known as the independent t-test. Okay, the independent two sample t-test. So what this does is that it compares the means of the two independent groups. So you have two independent groups, okay, to determine if they differ significantly. Okay, so you should notice that groups should be independent, like the name suggests. Okay, so an example would be, do male and female students differ significantly in average exam performance? Okay, and last one, we have what is called as the paired t-test. So this one compares the means from the same group at two different times, or from matched pairs, to see if there is a significant change. Okay, so a good example would be maybe you are trying to see if the blood glucose level of a patient changes after you do something. So maybe let's phrase this question: did the patient's blood glucose levels change significantly before or after a 6-week dietary intervention? Okay, so what to note is that under the one samples t-test, you have a known population mean or hypothesized. Then under the independent t-test, it's comparing, you are trying to compare the means of two independent groups. Okay, then under the paired t-test, like the name says, paired, so you're trying to compare means from the same group at two different times. Okay, so quickly, before I show you how to perform this, let's establish the scientific background. Okay, so going here under the independent t-test, so the test will use what is known as the dependent variable, and this dependent variable can also be known as the test variable. Okay, then you also have the independent variable, and it can also be known as the grouping variable. So it is important to note that the t-test can only compare the means of two groups, okay, the means of two groups. So it cannot make comparisons among more than two groups. Then in a case where you have more than two groups, you will need to employ what is known as the ANOVA, the analysis of variance. Okay. So there are assumptions or conditions that must be made before we run the test. So the first one is that, remember, you should have a dependent variable. Okay, but this dependent variable should be continuous. In other words, it should be a number and it should be measured on an interval or a ratio scale. Then when it comes to the independent variable, it has to be qualitative data, or it has to be categorical in nature, and it should have exactly two groups, okay? So the dependent variable should be continuous and should be measured on an interval or a ratio scale. Then the independent variable should be categorical and it should have exactly two groups. Then you should also have a random sample, independent samples, normal distribution, and you should also have homogeneity of variances. Okay, right? So let's quickly move on to other things to consider. So you should also have a balanced design. So just make sure that in your the subjects in each groups, they are balanced. For example, if you have group 1 and group 2, okay, make sure you have equal number of people in each group. Then you have a balanced design to avoid bias. So the hypothesis, the null hypothesis, still states the two population means are equal, and the alternative will state the population means are different. Okay, so quickly, let us now dive into the interpretation before I do the actual analysis in SPSS. So the interpretation, as our culture is, if p-value is less than 0.05, we reject the null hypothesis and conclude that the means are different, okay? If p-value is greater than 0.05, then in this case, we fail to reject the null hypothesis, which means the means are exactly, or not exactly, but the means are the same. Okay, the population means are the same. Okay, but it is important to note that, remember, one assumption we stated is the homogeneity of variances under the t-test. Okay, so in most instances, you find that this assumption has been violated. So the t-test will produce actually two tables, one for the Levene's test, which is on the left, and on the right, you have the independent t-test results. So how do we interpret this now? So you first start by interpreting the Levene's test for equality of means, because we have to equality of variances, sorry. Because what we need to do is that we have to make sure that our variances are equal in the two groups. Okay, so the output in the independent samples t-test will have two rows. The first one will be equal variances assumed, and the next one will be equal variances not assumed. So which one do you decide? When do we decide? How do we decide which one we should interpret? So the key lies here. If Levene's test indicates that the variances are equal, that means our p-value should be greater than 0.05. Remember what the null hypothesis, what happens to the null hypothesis when it's greater than, when p-value is greater than 0.05, we fail to reject the null hypothesis, which means it's true. Indeed, in this case, the variances are equal. So you interpret the Levene's test, okay? And if the p-value is greater than 0.05, that means our variances are equal, and you should rely on the first row of the output, equal variances assumed, okay? If the Levene's test indicates that the variances are not equal, you would expect your p-value to be less than 0.05. So in this case, you rely on the second row of the output, which states that equal variances not assumed. Okay, so that is a recap of the independent t-test. And we have the paired t-test. The assumptions are similar assumptions. The only difference is that you are now dealing with paired samples. So quickly, let us do an analysis in SPSS and see the results and try to interpret it together. So before we go, I have this problem statement here. So this problem statement was actually obtained from the Kent University website, that is SPSS statistics tutorials. This is where I got my problem statement from. So in our sample data set, the data set that I will import in SPSS, students reported their typical time to run a mile and whether or not they were an athlete. So suppose we want to know if the average time to run a mile is different for athletes versus non-athletes. So this will involve us testing whether the sample means for the mile time among athletes and non-athletes in your sample are statistically different. Okay, so you can use an independent samples t-test to do that. So quickly, let us go into our software SPSS. So this is the software. So I'll quickly go on the file and open. What I want to open is I want to open new data. All right. Sorry, let me double click that. So I'll navigate to the folder where my data is actually saved. So my data is saved in, let me just navigate here. Okay, in this folder, which is named Gabri. And then you'll notice here that I can't see anything because the file extension or the file type is spss.sav. And the file that I want to import is an Excel file. So for that reason, the Excel file will be hidden in this case. So you have to change here and navigate, click the Excel extension. So I've clicked the Excel extension and I can see that all my Excel files, in this folder, they are now visible to me. So what I want to import is the sample data set 2014. I select it and I click open. All right, so just give it a little bit of time. Should be able to open within a few minutes. Okay, and here just click OK. Right, should load. All right, so I have successfully imported my data in SPSS. So importing your data in SPSS is not something which is difficult. So quickly, let me look at my variables. So remember, I'm looking at the variable athlete and also the variable that is the variable minute duration. Where is it? It's here. All right. Okay, remember our problem statement. Okay, so the athlete variable has 0 and 1. So 0 will mean someone is a non-athlete and 1 will mean someone is an athlete. And this one, duration, is our dependent variable. So from the assumptions, we said the dependent variable has to be continuous or measured on an interval or ratio scale. So when you look at the minute duration, it qualifies, it can be measured on an interval or ratio scale. Now, coming back to our independent variable, we said it has to be categorical, okay, or qualitative data, of which this one is categorical. Okay, we're looking at, I'll code it later. Okay, so we're looking at non-athlete, 0, which means non-athlete, and 1, which will mean an athlete. Okay, and this one, from the assumptions, it has exactly 2 groups, which is athlete and non-athlete. So for that reason, then this data set qualifies for us to conduct what is known as the independent t-test. So maybe before I do that, I would like to visualize and create what is known as the box plot so that I get to see what is happening. So let me go on my Analyze tab. Okay. Sorry, not Analyze. Yes, Analyze. Then let me go on the descriptives. Okay, so I'll go on Analyze, then descriptives. Where is it? Descriptives. So I'll just go on the descriptives, then I'll navigate to there. So Analyze, descriptives. No, I've gone to the wrong thing. I've done the wrong thing, sorry. So I have to go on Analyze, then descriptives, then I'll go to Explore. Okay, so what I want to explore is in the dependent list, I put the dependent variable. I have to put the dependent variable. That is my minute duration. Where is it? Where are you? Okay, here we go. So I put it there. And then in the factors list, you can put in your independent variable. Do that, then click on the plots. What I want is a plot. I don't want anything else. So I've clicked on the plot. Okay, so let's check. So we have the box plot here. It's actually checked. Okay, and all I have to do is let me click continue and okay. Then let me see the output here. Okay, so we clicked together with actually with the descriptives. Okay, so you can disable that. So this is my box plot. So if you don't know how to interpret a box plot, check out for my other videos. So this is your minimum value, that is your maximum value, and this is your median. So the concept is that if the means between the 2 groups are equal, we expect also the box plots to have almost the same height. So from this, you can tell that the means are not equal. All right. So now let's perform a t-test now. So go on analyze, then compare means, then independent samples t-test. Then remember those things we talked about. We said the dependent variable can also be called the test variable. So let's put the dependent variable in this case, which is our mile-minute duration. Let us put it there. Then we have athlete T, which is our independent variable. In the grouping variables, let's click on options, leave the confidence interval percentage at 95. It's just okay. Oh, sorry. So let me just put this again. Now you see something which says define groups. So for the grouping variable, the independent variable, you need to define the groups. So you click on define groups. Okay. So what exactly is group one? How many groups do I have? I have two groups. I have 0, which means someone is a non-athlete, and I also have 1, which will mean someone is a non-athlete. So for the cut point, you can also use it if you have continuous variables, okay? And when you do that, you can put a cut point, which will split your data into exactly 2 groups. So in this case, I just put 0, which means non-athlete, and 1, which means athlete. Then I click continue, and all I have to do is click OK, and wait, and let us see the magic. So this is the output that you have. Okay, so this is the t-test output. So what you have, the first one with a table named group statistics, you have actually the descriptive statistics. So that is mile-minute duration. That is your dependent variable, and athlete has 2 groups, 0 and 1. So remember what 0 and 1 is. This is non-athlete and this is athlete. And so it's telling you the sample size 0, 226, 166, and this is the mean for each group, and this is the standard deviation for each group. Now let's move back and interpret our independent samples t-test. So if you check here, you have what we explained in the PowerPoint. You have equivariances assumed row and equivariances not assumed row. And you also have the Levene's test for equality of means, and then you have the t-test for equality of means. So you need to interpret these systematically, okay? So we start with from the left going to the right, okay? So we start with the Levene's test for equality of variances. So under the Levene's test for equality of variances, check the sig, okay? So you check the sig. The sig, which is also the p-value, you check this, and if it is less than 0.05, that means our variances are not equal, okay? From the PowerPoint, let me just take you back. Let me just take you a little bit back here so that you get it. So this is where the whole logic is. So if Levene's test indicates that the variances are equal, then we expect our p-value. We expect our p-value to be greater than 0.05. If Levene's test indicates that the variances are not equal, our p-value is less than 0.05. Okay, that is where the logic is here. That is where the whole concept is. So let me go back to my output. Okay, so here I've checked for the Levene's test, the p-value is less than 0.05, and hence the variances are not equal. And therefore, I go with the second row, which says equal variances not assumed, and then I interpret everything which is here. So the T is the t-test, okay, and DF simply means the degrees of freedom. And here now I have the sig two-tailed, which is the p-value, which is less than 0.05, okay? And here I have the mean difference, and I have the standard error difference, and I have the 95 confidence interval of the difference, which is the upper bound, the lower bound, and the upper bound. So remember, we are interpreting this row, which is on the bottom, and our p-value again for the t-test, it is less than 0.05. Okay, so remember, if p-value is less than 0.05, then that means there are statistically differences which exist. So just going by this, so we said T, when we start with T is the computed test statistic, okay, and DF is the degrees of freedom, and now we have what is known as the significance, okay, and the two-sided corresponding to the given test, which is the p-value in this case. Okay, and then we have the mean difference, and then we have the standard error difference. So what can we conclude from these findings, if at all we are following what we are trying to interpret here? So we are saying since p-value in this case is less than 0.05, which we are using as our since p-value is less than 0.05, then we can reject the null hypothesis and conclude that the minimal time for athletes and non-athletes is significantly different. Okay, so based on our results, we can also state the following. There was a significant difference in the mean mile time between non-athletes and athletes. Then you can cite the statistics, which is this, and you can also include the degrees of freedom and then also the p-value. Okay, I don't know if that makes sense. Then coming to this, we can also, this is the mean difference. So we can also say the average mile time for athletes was 2 minutes and 14 seconds. You can see this, 2 minutes, 14 seconds, lower than the average mile time for non-athletes. So this is how we interpret the t-test. So you first start with interpreting the Levene's for equality of variances, and then move on to interpreting the t-test for equality of means. Thank you so much for your time, and see you in the next video on the paired t-test.